Welcome, everybody. We are back with another meetup, Data on Kubernetes. This is meetup number 3, which will be followed by meetup number 4 this week. This meetup is actually meetup 29 officially. We're kind of going back because we had to reschedule. That's how things work in 2021. We're very, very happy to have Yury here with us. If we can get the links on the screen just really quickly. As a reminder to everyone, if this is your first time, we are a very welcoming community. We're always looking for folks who are interested in giving talks, sharing their knowledge, no matter what level they have, no matter how much experience they have. If you're a total beginner or if you're a super advanced Kubernetes veteran, you always have a place in our community. So feel free to check us out on LinkedIn, on Twitter, on Slack. We're always looking for different folks to get involved. Also doing things in different languages. Yesterday, we had our first meetup in Spanish. After this meetup, we'll be having our second meetup in Spanish. Yury, I'm sure that you speak more than 2 languages, so we may have to get you to do something in the future. How many, well, anyway, let's get to know you. Yury, who are you, how are you, and how many languages do you speak?
Cool. Hi guys, I'm Yury. I'm principal engineer working for Absa. I'm a Russian guy who lives in Czech Republic and works for South African bank. So quite a amount of languages. So yeah.
Okay, good. I mean, and those are just, spoken languages. And we can talk about, we were talking earlier about infra as code, then there are different other languages that we'll probably be touching on. And so you have a background, you've been working with infrastructure for how long?
For a long time. I started back in the university, like a sysadmin in the university. So more than 15 years I'm touching infrastructure. So the route was pretty interesting, like from sysadmin then to, I relocated to Czech Republic to work for SUSE Linux. So I was doing like system engineering / QA stuff there, with a focus on operating system and some, back in the days, super fancy cloud stuff. So it was OpenStack, SUSE Studio for building images, which is was very new stuff back in the days. It's pretty much before Docker. And yeah, it was pretty cool there. And then I moved to Good Data. It is business intelligence, actually data specific startup. I was running there as part of a small team. We were running OpenStack based infra before OpenStack was packaged for any distro actually. So we were like running our very own. I think it was OpenStack Folsom, kind of yearly release of OpenStack, relatively yearly, with many rough edges. But we managed to scale it over multiple data centers, and it was a pretty cool experience. Then it was iFlix, which is kind of Netflix, but based in Malaysia and for another part of the planet. Also like half planet scale. Was pretty cool. We were running Kubernetes on top of AWS before EKS was available, so it was also fun. And I think it was mentioning it was pretty cool projects there. So we had reliability issues, and we had to rebuild all of this our own automation for running Kubernetes on top of AWS. So we had that issues, kind of like Ansible spaghetti code, and we decided to switch to kubeAWS Golang-based open source project, which is already deprecated, but it used to be like pretty popular back in the days in 2017. It was capable to produce a CloudFormation manifest out of like relatively simple YAML with reliability in mind. And to actually prove that we achieved the goal, we wrote some automation, which was like, it wasn't like chaos testing, it was more like deterministic disaster testing, which was killing like master nodes, etcd cluster, and all this disaster scenarios. And we proved in a pretty objective way with automations that our clusters can recover in 6 minutes without any human intervention, even in case of total disaster when etcd cluster just destroyed over all availability zones, including automatic recovery from the backup. So it was pretty cool there.
Wow, that does sound pretty cool.
Yeah.
Good stuff. And so, you've seen this whole evolution. What we were talking a little bit before we got started, you've seen this whole evolution. And one of the things that you've spoken about is, test-driven infrastructure. Some of the things we're going to be looking at today, we can talk about load balancers. Could you explain just a little bit, or maybe we want to save this for your presentation, but moving from a load balancer to a scenario in which it would be necessary to have a global load balancer. Can you touch on that a little bit?
Yeah, actually, it's very good introduction to the stuff we are going to talk about to the project. So it originated in Absa by the need that standard. So why first of all, why global load balancing, right? So Absa footprint is mostly on-prem now. It's kind of hybrid with transition to AWS, which is pretty common nowadays for enterprises to transition to the cloud, but still a lot of footprint in our own data centers. And to achieve high availability and reliability, usual deployment scenarios to deploy application in parallel to two different Kubernetes clusters, which are geographically located in two different data centers. So basically limiting failure domain and duplicating deployment over two geographies. So that's why GSLB, global service load balancing in like a classic understanding of it. And Absa tried multiple vendors and mostly like global load balancing vendors. They're doing their stuff pretty well, but still there is disconnection from a cloud native Kubernetes scenario. So like you're running your clusters, but there is no proper ability to hook in control over global load balancer from within the Kubernetes manifest, right? So that's why we decided to build our own. So we didn't find any alternative, even proprietary, which would satisfy our idea. And our idea and goal of the project is to first like configure global load balancing strategy and traffic steering in declarative way with a Kubernetes-like manifest. So like with yet another CRD, customer resource definition. So Kubernetes is very good for from an API extension standpoint, that regards. And associated controller, obviously. And another main part of it is not just enables this Kubernetes power, abstraction power for operation guys and like whoever wants to control the network part, but actually to provide an application development team almost full control over the global traffic steering and actual health checks. So application team can just use a special GSLB resource, specify standard ingress routes there, which would correspond to their services they're about to expose. Service will transitively will be looking over pods, and so basically load balancing health checks will be based on a pod liveness and readiness props, pretty standard Kubernetes primitives, and associated strategy. Currently, we support simple strategies of Roundrobin and failover. So basically, Roundrobin will be in a round manner balance the traffic over two geographical locations, and failover will pin to the some main one. And in case of workload is not healthy in the main data center, it will automatically fail over the traffic to a secondary one. So that's the main scenarios for us. And yeah, these two strategies are pretty well tested now in post production and pre-production Absa footprints, and yeah, all this stuff is fully open source, and it's also worth mentioning that we designed this solution without any control cluster, without single bottleneck. There is no single centralized instance that can fail and screw things up. In contrast, KGB controllers are deployed to a target clusters, to the same clusters where workloads are running, and basically they sharing the status also via the DNS protocol, because it's not secret information with the healthiness, right? So they returning consistent responses from the both from all GSLB enabled clusters. So basically, it's designed with the reliability in mind for itself, and all this traffic steering is based on DNS protocol. with all the like reliability as it's running internet, and also obviously some limitations. So like, for example, DNS TTL, time to leave, whenever workload is not healthy, for example, failover effect will be visible for a requester, for an end user in a DNS TTL span. So we usually operate with 30 seconds, and it's enough for us. So it's fast enough for a global scenario. So yeah,
All right.
And I can demo it in a live session.
No, good. And that's exactly what I was going to say. Why don't we jump in right into your presentation if you want to share your screen?
Cool. Yeah. So do you guys see my very colorful slides?
Yes. So, very minimal, very artistic.
Yeah. So pretty much what I already mentioned. From implementation standpoint, we are following operator pattern, and operator pattern from original core S meaning, right? So we are automating some infrastructure tasks with a specific Kubernetes controller, and we heavily utilizing standard Kubernetes primitives. So ingress services, endpoints, and pod probes are all in action, and we basically the most heavy lifting of cluster status is done by Kubernetes itself and associated primitives, and we just gathering the status, resource healthiness, sometimes transitively through endpoints, and using that information in a global load balancing scenario and associated DNS responses. So, so basically, there is no magic there. We try to design it as simple as possible. And one important thing, so we are using external DNS as an integral part of the project, but we are using it only for configuring zone delegation in a environment, in a target environment DNS in some DNS provider like Route 53 or Infoblox or NS1 or something else. We tested only 3, but external DNS as a project supports more. The thing is, so like we are not pushing there into some external control zone any records. We configure zone delegation, and we basically making KGB itself and its core DNS processes to be authoritative DNS server, which provides dynamically crafted DNS responses according to GSLB strategy specified. So that's the design. So from implementation standpoint, we based our work on operator framework, and operator SDK is a very nice project to actually bootstrap some operator controller. When you start a new project, it provides a very nice kind of skeleton and a way to define CRDs and a structure for a controller and a reconciliation loop. It enabled a very good start of the project. Currently, it's more complex than original structure. Obviously, it's kind of distributed system by itself, but operator framework gave us very good start, and currently they switched to Kube Builder as an engine. We followed them as well, and so it's a Kube Builder, the one that is originated by Google, plus some CLI helping helper CLI on top. So very nice project. If you start a new operator, can highly recommend. We're also using core DNS as a part of KGB deployment. That's the part that is actually providing the DNS responses, and it reads the state from etcd database. So we used to run dedicated etcd cluster, like following the external DNS projects with a Sky DNS. Basically, external DNS was reading special DNS endpoint CRD, and populating etcd database in core DNS use the etcd dedicated cluster as a backend, but very recently we got rid of this part because it was relatively unreliable, especially after etcd operator, which is responsible for etcd cluster deployment, got deprecated. So we, in long running cluster, we faced some reliability issues. So we wrote a core DNS plugin which is capable to read a CRD directly without a dedicated etcd cluster involvement. And basically, we just using now a standard Kubernetes API and underlying Kubernetes etcd without duplicating the etcd deployment efforts. So now it's much more reliable and seriously less running processes in a KGB namespace. And external DNS is a upstream project that we are using for automated zone delegation configuration in a HDNS and a target environment DNS provider. And everything is controlled with a single customer source definition. So we have support for 3 DNS providers as we name it in the project. So it's Infoblox, it's our main DNS provider for our on-prem scenario. So we implemented first. Then for AWS, we obviously using Route 53, and in the close collaboration with NS1 guys, actually operating both on-prem and in the cloud. We also integrated with them. And again, as we use an external DNS, if you guys running something different, there is a good chance that it will work for you relatively easily if you try this external DNS provider together with KGB, but provider API coverage and quality heavily deviates within external DNS project, so there are no guarantees. But both Route 53 and NS1 is very well maintained. Oh, and we have integration with some another open source project like Admiralty, which is a cool project for multi-cluster scheduling. So we paired, we created some integration and a guide how you can use an Admiralty controller for multi-cluster scheduling of workloads, and using KGB next to it to enable load balancing for this multi-cluster workload to expose them in a GSLB way. So you can jump to a demo, but just to demonstrate you some overview. So we have a KGB IOs in a concept section. We have some architectural things. Just to reiterate, so we have some DNS, some service or human who is producing DNS request, right? And it goes through HDNS provider. So for example, Route 53, on Route 53, layers on delegation is configured, and it involves, for simplicity, we will talk only about 2 clusters. It's actually the main scenario that we are running in production. So we usually have a dedicated cluster for specific workloads that run in pair. And yeah, on a DNS, HDNS provider, zone delegation is configured. So, and the zone delegation is including the worker, it's either worker nodes of the clusters where 53 UDP is exposed, it's our on-prem scenario, or it's a NLB network load balancer in AWS, which is sits in front of these workers. So, but it's just implementation detail. It's important just to take into account this, both of the geographically distributed clusters are going to take care of this specific DNS zones that is GSLB enabled. And the KGB controller is going to create or monitor associated ingress. And through ingress and which is referenced Kubernetes standard Kubernetes service primitives, it will monitor the workload healthiness through basically pod health status. Effectively does it through service endpoint array, which is populated from more than 0 when at least one pod is healthy. So it's again, it's done by Kubernetes itself. We didn't have to implement this logic, so which is another case for the Kubernetes power, so we can build on top of the and inherit this cluster primitives, abstraction, and overall benefits. So that's roughly high level how it works. And we can go to a live demo. Do you guys see my console?
Yep, perfectly.
Cool. Thank you.
Yep.
So in a right pane, we are running this sample curl that iterates over test FQDN. So KGB is already deployed in AWS and 2 EKS clusters. One is in Africa, Cape Town, another one in Europe, Ireland. So let's just look around, get nodes. So you'll be just double sure where we are. We are in ULS1. So we are running KGB in this KGB namespace. So controller is running. So it's the main controller where actual Golang code with a reconciliation loop and associated automation and logic resides. This is CoreDNS that is responsible for DNS part of operations, and external DNS, that's the one that configures this zone delegation automatically in a Route 53 in this specific scenario. So how we actually operate, so everything is installed, so how we enable global load balancing for some workload. So in a test GSLB namespace, we have some workload running. I'm using PodInfo, which is pretty popular minimalistic demo application from Vworks. And it's just standard deployment, nothing special there. And I think we want to expose it. Yeah, so obviously it has associated cluster IP service, so front-end PodInfo. And if we want to expose it, we can just create GSLB kind. So so that's an initial spec. It's already there, but I'm just to demonstrate the specification. So our special API version, kind GSLB, standard metadata, and main part of the spec is actually embedded ingress, which is one-to-one to the standard ingress. It's actually the same Golang type and how it's implemented in a Golang code. And here we specify the standard rules and reference to standard service, so nothing special about it. We just have an embedded ingress spec there with information of the Kubernetes service we want to expose. And in addition to that, we compose a special to GSLB part of the spec, which is strategy. And here we are specifying failover and the primary geographical tag. Basically, we are saying that the main primary cluster is Europe for now, for this workload, and it should return Europe, like we see it here, until workload fails. So, and we can quickly test it. So it returns like here. So here is on the right pane is just a curl loop, right, which is gripping this geo tag, and the workload in this cluster was especially we propagated this geographical tag just for visibility, right? So we are using this tag for demonstration purposes to be aware from which data center the response is coming. And we obviously can use DoK to figure out what kind of responses it is returning as of now. So, and next to this workload, we already have GSLB resource, custom resource deployed. So it's already there, exactly one-to-one to the YAML files that I showed to you before in Vim. So referencing front-end PodInfo, picking up the service health status, determining that it's healthy, and returns the specific set of arrays. So what is this set of array? We can actually figure it out quickly. We requested the standard resource, right? So for failover, it's this standard ingress resource for failover. It created, it has an associated NLB sitting in front. For like in this demo, we're using standard ingress Nginx controller. KGB is designed pretty much ingress agnostic way. We also tested ALB, worked nicely. So whatever is exposed here in a status of ingress in address is going to be used as a part of this DNS response by KGB. So basically, it works in consistent way with the standard resources. So we can dig this NLB created, and you can see that's exactly the one. So that's the same IP address set. In the meantime, what is happening in Africa? So exactly the same situation, the same workload is deployed there. Same GSLB one-to-one, nothing is changed for the specs. So they are identical. The single same file, YAML file, is a source for both custom resources in both clusters. And here it just by initial deployment, these data centers are geotagged differently. So European one is tagged as European one, is US one, and African is obviously as South one, one-to-one, accordingly to the associated both regions. Here workload is also healthy, but given that we are utilizing failover strategy, it also returns the IP addresses for Europe, because the primary is an Europe data center. So both clusters are aware of each other's state, and they are returning consistent DNS responses. So they're aware of what is happening with the workloads that they are running. They thinking the state of front-end pod info, which is GSLB exposed through this FQDN. So let's emulate some failover. So we can switch back to the Europe. You can double check that we're in Europe, so US one. And we can basically try to emulate the failure by standard approach. We just scale down to front-end pod info to 0 replicas, right? And keep an eye on what's happening here. So currently it's 503, so it's this DNSTTL limitation. So it's not immediately picking up the update, right? In the meantime, we can look at what is happening in GSLB status. So it's already returning a different set of IP. The African ones, it picked up that it's unhealthy. What is happening in Africa? It's healthy and it's returning its own IP address. So they're again consistent. They already shared the information. So after DNSTTL will be expired, we should see an African geotag in our test loop. Hopefully pretty soon. Take some time. Yep, and here we go. It successfully failed over to Africa in an automated way. So yeah, as you can see, everything works fine, but we are operating in the limits of DNS protocol still. So for us, it's fine, especially it's global scenario, right? It's not in cluster. So both geographical failover successfully happened. Do you guys have any question at this point in time?
Yeah, I had a question from someone on Slack. That was saying in the KGB documentation, it says that one of your goals is not to reinvent the wheel and to use other proven and supported CNCF projects and other open source projects when possible. What other projects or solutions do you use in the building of KGB?
Yeah, great question. So I slightly touched it, but it's cool to talk about specifically on this topic. So again, these are three parts, like in the recent version of KGB. This is controller, so which we built on with operator SDK, but it's our custom, the project stuff, right? Where our own logic is implemented. Another CNCF project is definitely core DNS that we utilized. We didn't implement our DNS responding facility on our own. We used core DNS and integrated into KGB, and we used SIG network. I'm not sure if it's part of CNCF, most probably not, but it's definitely part of Kubernetes SIG network external DNS project, which is responsible for integrating these outside of the cluster DNS services. So we heavily using that, and we also reused special CRD from external DNS CRD source subsystem, which is called DNS endpoint. So it's not our invention, but we are using it heavily. So that's how it works under the hood. Better for failovers that we demonstrated now. So what controller does, it populates this DNS endpoint CRD, this one. And that's basically, and it acts as a backend for core DNS. And that's how we creating these DNS responses. So it is dynamically populated by a controller. And these special local targets, FQDN is actually, the clusters are cross-polling each other and they're sharing the healthiness state. So European cluster asks directly a NS server of African cluster and asks for this FQDN resolution and basically reads in the records. And if a records is empty, then it's treated that another cluster workload is not healthy. So it's simple information sharing approach. So initially, like kind of naive approach would be to expose Kubernetes API mutually for clusters, but we decided to go specifically just DNS-based information exchange because we got rid of whole class of problems. API exposure itself, SSL rotation, certificate rotation, and authorization, authentication, additional RBAC. Definitely, like, as this information is definitely not sensitive. Anyway, it's exposing as a part of the DNS response, the DNS-based information status exchange fit into the picture really well. Oh, yeah. Does it make sense?
Yep.
Cool. So we can actually quickly make a failover back. We getting back to EU, and we can scale back to a couple of replicas. We can check the status. So it will take another reconciliation loop. So for controller to pick it up and reflect for sure. So here we go. It's already healthy. already European response, and another DNS TTL and information sync, status sync between two clusters, and we should see an European tag here in our control loop pretty soon. So yeah, here we go. It's already returns. It's already steering traffic back to Europe. And here we didn't see any 503 because workload in Africa was healthy. So it didn't hit unhealthy workload. So no 503 responses. So actually, from time to time, it's very useful for cluster operators. So like, and for teams. We recently had an interesting case where workload was running it was indicated as healthy workload because pods were running and liveness and readiness props were fine. Meanwhile, from correctness of the service, it was broken because database state wasn't fine in one of the actually primary cluster. So what we did is just patched primary geotag to a secondary cluster in both of the clusters in picture, and we basically recovered service availability in 1 minute. So an outcome of that, like it still was like semi-manual, meanwhile quick because it's declarative. And another step to that, application team responsible for the service, they extended their readiness prop, catching this, making it like small end-to-end test to the database. So basically, in a next, if the same stuff will occur in future, it will be detected automatically thanks to this advanced pod prop. So it is very flexible and it gives power to application teams to control this traffic and health check and overall reliability scenario around the services. And yeah, we intentionally do not employ any kind of end-to-end HTTP checks, which are very standard in the classical load balancers. And traffic doesn't go through any centralized instance. We are not passing the traffic through. So everything is DNS-based, and it's hitting the workload and associated ingresses directly, or like to a local load balancer like NLB, depending on the environment and the specific setup. Yeah, it may be worth to demonstrate additional strategy that we use. So it's a pretty like a demo YAML, which encapsulates, which just demonstrates special different statuses of GSLB resource. So like non-existent, unhealthy, and a round-robin this strategy that we're about to demonstrate. And strategy type round robin doesn't have any parameters. Pretty much these are common for split brain mechanism of KGB for in case of horizontal network partition, and DNS TTL seconds provides you ability to override the default 30 seconds one. So this resource is already also existing, so it exists there in a test GSLB. Yeah, and as you can see, it provides a mixed response. So these three IPs are from Europe, these ones are from Africa. And we can definitely end-to-end test it with DoK. And we can correlate. Yeah, and it's super, like sometimes it's random all over the 6 IPs, and it's not deterministically flipping, so it's like mixing them up. So the immediate switch of the geotech is not guaranteed. And we have a backlog like to implement a consistent round robin to enable the 50-50 traffic split. But so far, this random approach works for us pretty well. So if we emulate yet another failure, workload is actually still the same behind both of the strategies. So as you can see, this round robin, it's still referencing the front-end pod info, exactly the one as a failover one. So we currently utilizing sample GSLB traffic steering over the single sample workload. So if we look at the status of a round robin, so it's already detected that this one is unhealthy, and it returns only single cluster response. Yeah, we currently in Africa, so we scale down the African pods and it returns the European one. And after some time, yeah, it's already picked it up. So it returns in like end-to-end only European IP addresses. And here, curl, we have some caching. I definitely have some caching here. That's strange. No, most probably something around this killer, but yeah. The actual raw DoK response is probably pointing to you. Yep. And if we scale it back, we can check it still didn't pick up the health status. Maybe it's still getting up. Running. So detected is healthy and returns response from both of the clusters. So that's for round robin. So I guess that's it for the demo. The question, please.
Yeah, got a couple here. Just one second. From a usability perspective, obviously you're somebody who has a lot of experience, right? There's no secret about that. From a usability experience perspective, for folks that are accustomed to working with load balancers in general, on a scale from 1 to 10, how difficult would you say it is to jump in to start using KGB?
Well, if you have if everything like is set for you, or like you went through initial installation phase, which is not super small, but relatively simple, because like not super small because you still need to deploy to different clusters, right? So you need to employ some GitOps workflow ideally to deliver KGB controller itself. But assuming it's all installed, it's the control is limited, like it's simple kind, right? That's it. And the rest is a standard Kubernetes stuff. So if you're familiar with Kubernetes from a kind of application developer perspective, it is very simple service to consume. And in addition to that, well, we obviously gathering feedback from our teams, and we have a small exposure external users who are experimenting with a KGB for in their own infra. And we created this trick which our customers kind of liked. So I demonstrated you a direct creation. So in a classic like very basic scenario, we would just use this and we would apply, and that's it as a standard standard Kubernetes object. But pretty frequently, the ingress, so and a controller will create a GSLB resource for you and associated ingress, which is used for a global load balancing scenario. In the meantime, it is pretty frequent that application teams already have a bunch of ingresses. Well, ingresses are around for their services, right? Mm. So instead of create another GSLB ingress in parallel, they can use a special annotation and extend their ingress spec, put the KGBIO annotation tag. Controller will pick it up because it monitors the ingresses in a target namespace and will create this guy, this kind GSLB automatically for you. So application teams, if they want to, they can follow this way and not managing specific CRD at all. They can operate just with their ingress. And people usually like it. So they don't have to modify their Helm charts. They just drop in a couple of annotations there and GSLB is getting enabled. So it actually helped work pretty well for us in terms of adoption of KGB within the company.
Mm-hmm. And regarding that as well too, yeah, touching on that about like, you know, you've been in different companies and you've seen different philosophies. Working for a company that's a, you know, a major player in the financial services sector, do you see it as a growing trend that more and more companies like Absa will be using open source technologies like the one we've been seeing today?
Well, definitely Kubernetes has a great momentum, like it's almost everywhere now, and it's not just orchestrator, container orchestrator anymore. It's platform, right? And a lot of people building some sophisticated automation on top of this platform. And I think it's becoming like a common ground. I think it was Joe Beda Manai's talk, like Kubernetes is a platform of platforms. It's a very nice foundation, and a lot of organizations are consuming additional functionality and platforms on top of Kubernetes. So I definitely see this trend, and it's visible by CNCF, for example, as in their end user community. There are a lot of companies who joined, like from Adidas down to Bloomberg, and so like a spectrum of business active users. Like it's very huge, and people are trying to collaborate on their solution, and overall it looks really great and promising. So currently we have in the community a lot of operators that solving a lot of problems and challenges in an automated way, which pretty much was hard to imagine this level of automation like just 3-4 years ago. It's really great.
It's true. It's true. So as you said, there's a lot of momentum. There's a lot of movement. I think a lot of companies are seeing that, A, this is good for business reasons, and also the tech talent is interested in using these technologies. So I think that combination is what gives it so much potential. With that in mind as well, too, in your experience, do you feel that, because, you know, in our community, data on Kubernetes, we talk a lot about, you know, running stateful workflows, stateful applications. Is this something that you're experiencing as well?
Well, we definitely have a mixed style of workloads, and big data is a huge part of it, for sure.
Yeah. No, just because, you know, some people, philosophically speaking, will say, keep everything stateless, you know, just leave the data outside Kubernetes, it's not worth it. Whereas what we're seeing in the very foundation of our community is more and more use cases where it seems that it's actually better and more practical to have everything all in the same place so that you don't have to be, you know, separating or distancing things out.
I have yeah, we can actually unpack that. So I would actually leave Kubernetes clusters as a clusters pretty much immutable and stateless, but it's another very active new project within Absa and in community as well. You probably heard about Crossplane. Mm-hmm. So yes. Yeah, it's also getting traction. So the overall idea is to use Kubernetes as a common control plane, not only for in-cluster resources, but also for managed cloud services. So that's where we can benefit from both worlds, all right? So still running infrastructure, declarative way, utilizing control reconciliation loop. Meanwhile, when we want to really offload like the data management, so like, because like maintaining state is hard in Kubernetes. So if there is a possibility to offload it and you can pay for that, it's better to do it really. So meanwhile, for example, so what cross-plane is can do for you is you can represent the RDS in AWS as yet another Kubernetes CRD, and cross-plane will deploy RDS for you according to the spec, and will provide a special secret according to the configuration, Kubernetes secret, and your application can directly consume the secret and connect to the database. So it's really powerful. And we're using, well, cross-plane is a huge topic on itself. It enables you also create additional IP abstraction in a declarative way, and it's really like it's changing the picture on a landscape of cloud infrastructure, the cold stuff. It's more like infrastructure as the data, and it's really promising. So we are heavily investing in that area as well, and it works very nicely together with KGB and all that stuff. I actually will be speaking on a cross-plane community day. It's the one.
The 4th?
Is, yeah, that's the one before the KubeCon. So I will share our experience how we actually deploying KGB on 100 of clusters, and we have like more than 120 clusters as of now. Wow. We are using cross-plane to deploy KGB automatically in abstracted way and a fully like GitOpsified approach. So.
All right. Well, we will definitely be sharing that in our community, because I think there will definitely be interest in that. Because like I said, is that there are different ways of looking at it. I think it does depend on the use case. It depends on a lot of different factors that have to be taken into account. But cross-plane is definitely a player there. So I just left that as a comment in our Slack. We're just about out of time. We do have other questions, but we'll just continue the conversation later on. Yury, thank you so much for sharing your time with us today. This is extremely interesting, very beneficial. Also very nice to see the actual, the coding aspect of seeing this come to life and not just talking about concepts on a surface level. So before we finish, we always have a tradition in our community that we like to, you met Angel in the very beginning. And so while you've been talking, Angel has been very carefully creating a visual representation of the stuff we've been talking about. So Gorka, if you can share our screen so that, Yury, can you stop sharing your screen? Yeah.
Yep.
Very, very good. So now we will share ours. So you can take a look and see what Angel was able to put together regarding all the different things you talked about. There is definitely plenty of information to be kept in mind. But it looks like it turned out quite well.
Wow,
so anyway,
that's super cool.
Yeah, but you did a great job. You did a great job, and he does too. Anyway, Angel he makes magic with the things that we're talking about.
That's really impressive.
Yeah, good. I'm glad you like it. We're very impressed with your talk, Yury. So it's very nice to have something that's very well explained, very practical, and then we get to see the value behind it. So thank you very much. We'll definitely be looking out for your presentation on the 4th. And looking forward to continuing the conversation in Slack. So once again, thank you for your time, Yury.
Thank you so much. It was a great pleasure.
All right, take care. Have a good one. Bye-bye.